Hi all, today we are going to see the design considerations of current commutated chopper. So why these design considerations are required? So last class we have already seen the working of current commutated chopper. We have seen under different modes how this will operate. These are the different elements. So the design parameters mainly tells us what should be the rating of the capacitor, what should be the minimum voltage rating of the thyristors that are required, what should be the value of the capacitor and inductor. All those things are considered as the design parameters. Those things we are going to discuss in the today's class. So last class we have seen that at the time from T5 onwards, so at the time of T5, that means at the time of T5, so that I have represented here, after T5 the freewheeling diode will start conducting because the voltage across the capacitor, the voltage across this capacitor will reach the Vs. So whatever is the load voltage if we calculate in this loop, after this, because the voltage, because this is crossing little above Vs, so this freewheeling diode will be forward biased. So your load current will start bypassing through this freewheeling diode. So ideally speaking, entire I0 should bypass through this freewheeling diode, but still the current through the capacitor will not reach 0 from this I0 at this instant T5. This is at T5. And this is at T6. So what is happening? It will slowly decrease from I0 to 0. The reason for this is the inductor which is there here, inductor will not allow the sudden change in the current. So whatever energy is stored in the inductor, that will be transferred to the capacitor. So that's why slowly the current will goes on decreasing and it will reach 0 when the energy stored in the inductor is completely transferred to capacitor. So that means we can tell that after this instant it is slowly decreasing. And when it is slowly decreasing, that means the current is still passing through the capacitor. So that's why that will be charged further and it will reach some peak value at T6. This is T6, so this is at T5. So it will reach the peak value which I can write as VCP. That VCP is the peak value. So now whatever the peak value comes, because when the current is becoming equal to 0, whatever voltage across capacitor is the same voltage will come across your auxiliary thyristor, because that decides the rating of your auxiliary thyristor. So that's why this is very much important. So the same thing I am mentioning here, at T is equal to T5, the capacitor voltage is Vs and the IFD start conducting, that freewheeling diode start conducting, but IC is not equal to 0. Why? The energy stored in the inductor is transferred to the capacitor. So Vc is increased from Vs to VCP during this duration. It is increasing from Vs to VCP during the duration T5 to T6. So at T5, the value of IL is equal to IC is equal to I0. So the energy stored in the inductor at that instant will be half into L into current at that instant, that is I0 square. So this energy is transferred to the capacitor. So because of that, what will happen? The voltage in the capacitor is increased. Or otherwise, if you represent the energy that is transferred to capacitor, that will be half times of C into difference in the voltage between T6 to T5. That means what is the value at T6 minus T5? So T6 is VCP minus Vs whole square. That will be nothing but, because half CV square is nothing but half Li square, from that only. Half L into I0 square. Here why it is I0? Initially it is I0, finally it is reaching 0. So I0 minus 0 whole square. So from that this is coming. So from this, if you simplify it, you will get the value of VCP, because VCP minus Vs whole square is equal to half will cancel in both sides. And this C will come to second side. This will become L by C into I0 square. So VCP minus Vs will be square root of I0 square into L by C. So this will be I0 into square root of L by C. Then Vs came to second side, because here it is minus, it will become plus. So that's why VCP will be equal to I0 into square root of L by C plus Vs. Up to this much value it will reach. So now we have to see how to calculate the value of L and C, because I0 is decided by the load, that will be known to us. So how to calculate L and C, that we are going to see in the next section. So once you get it, substitute here, you will know the value of VCP. So let us now see what is the peak commutating current. What is the peak commutating current? So how much will be the current under commutation conditions, or otherwise what should be the peak value of the current that is passing through your capacitor? That is called as the peak commutating current. So this will be here. This will be ICP. This will be the peak commutating current. What is the peak value? So why it is required? So here you can see at the time of T is equal to T3, but the time T is equal to T3, what happens? Your current through your capacitor will reach I0. After that, your current will goes on increasing. As the current is increasing, because this capacitor will supply the load current plus, that remaining current will start circulating through the diode D1. As we have seen there, that the remaining current is passing through the circulating through the diode D1, so that reverse biases your main thyristor. That's why we have seen in the last class that between T4 and T3 it is a reverse biaser. So that means the duration for which your main thyristor is reverse biaser, that is from T4 to T3. So let me go to the diagram to explain this. So T4 to T3. So T3 to T4 that I am representing here. So what is happening? Whatever the capacitor is there, the current that is applied, one current will pass through your load, another current will pass through this diode and return back like this. So this, because it is passing like this, the drop will be plus this side minus this side. So it reverse biases your main thyristor. So that's why during that time your thyristor can recover completely due to the reverse biasing and come to again working condition. That means it is ready to operate again. So that is the duration, that is called as a P commutating current, because if the P commutating current means this maximum value. So your actually diode is conducting from this duration to this duration. So how much duration your diode is conducting, that is decided by the ICP. That means how much is the current of the capacitor above I0. So more the value, the more will be the duration for which your diode will be conducting. So that's why it is so much significant. That's why we are reading this. So let us go back to this waveform again. So here we can see that at t is equal to t5, the value of IC will be equal to I0, and it increases sinusoidally to the value ICP. It is increasing sinusoidal to the value ICP. So it is from value t is equal to t3. So please change this one. So it is changing from T3. At T3, the value of IC is I0. It is increasing sinusoidally to ICP. So gradually it is increasing. So during this time what happened? The freewheeling diode will start conducting. So the freewheeling diode current I can write as IC minus I0. This reverse biases the main thyristor. So this value of the ICP should be greater than I0 to reverse bias the thyristor for a sufficient duration. So we can tell that the value of this ICP should be greater than the value of I0. So we know the equation for the IC because it is forming the LC circuit or the tank circuit. So this tank circuit is discussed in lecture number 56. Anyone have doubt about how this equation come, you can please refer to that lecture. I am assuming you already have the idea about tank circuit, LC circuit, what will be the wave equation for the current. So the value of IC will be equal to Vs into square root of C by L into sine omega naught t, where omega naught will be equal to 1 by root LC. So this Vs into square root of C by L, all the elements are constant. So this I can write as ICP sine omega naught t. So this is the value of IC. So at the peak value what will be there? Vs into square root of C by L. So that I have substituted here, Vs into square root of C by L. This should be greater than I0. Or otherwise I can equate them by multiplying with some constant x. Or otherwise I can tell that x is the ratio of LHS by I0. So what is this one? This is nothing but ICP, or otherwise I can write x is equal to ICP by I0. So practically the value of the ICP should be maintained as high as possible, as we have to keep the figure, exact figure at which we have to maintain. So practically that value is maintained from 1.4 to 3 times, so that your thyristor, main thyristor, will get sufficient time to reconstruct or completely recover and again ready to operate again. So that's why this much duration we have to keep it. It will completely turn off. So from this equation number 1, I am just recalculating. I want the value of root C at a later stage. So I am calculating it. From this I can calculate root C. Root C, how you will get it? X times of I0 into this root L will come here. This will be root L divided by this Vs will come down. This will be Vs. Okay, this I am taking as equation number 2. So those we are going to discuss at a later stage. Then coming to the circuit turn off time of the main thyristor. So for how much time your main thyristor should be turned off or is turned off. So that you can see here this TC, it is from T3 to T4. When diode is conducting, it is reverse biased. That much duration it will be there. So we know the value of IC, that waveform what is passing, that will be equal to ICP sine omega naught t. So the value of IC is equal to I0 at T3 as well as at T4, because you can see the current waveform IC. IC is what is happening, sinusoidally increasing. It is reaching I0 at T3 and gradually it is increasing further. This is at time T3. So gradually increasing, reaching its maximum, again coming down, reaching again I0 at T4. Same thing I am mentioning, it is at T3 and T4. And IC is equal to 0 at T2 because it is starting from T2 and gradually rising. So I can tell that the T3 minus T2, you can see T3 minus T2, this value we have discussed in the last class, that is nothing but equal to theta 1. So the magnitude, that means at this point I0 I can write as, because it is varying sinusoidally, so ICP into, from this equation, ICP sine omega naught t, ICP sine At that instant, the angle covered is theta 1. So ICP sin theta 1 is equal to I naught. Or from this, I can calculate theta 1 is equal to sin inverse of I naught by ICP. Sin inverse of I naught by ICP. So let us proceed further. So as the main thyristor is reverse biased during T3 to T4, so we can tell that the main thyristor, that circuit turn off time, I can write as a T4 minus T3. So this I can write as, because omega t is nothing but the angle, so this I can write as omega naught into Tc, that is nothing but equal to, the duration will be, here you can see the total duration of this sine wave, this duration is pi. Out of that, your diode is conducting from after theta 1 up to pi minus theta 1, because only for this much duration diode is conducting. That means only for this duration your diode is, or thyristor is reverse biased. So this one will be, total is pi minus theta 1 minus theta 1. So total will be pi minus 2 theta 1. So I have substituted here. So this theta 1, from this equation I am substituting sin inverse of I naught by ICP. So when you simplify this one Tc, this omega naught will come down. This will be 1 by omega naught into pi by 2 times of sin inverse of I naught by ICP. Or from this I can write Tc is equal to, this omega naught is nothing but 1 by root LC. So I have substituted root LC into pi minus 2 times of sin inverse of 1 by x. So if it is asked in the numerical, calculate the circuit turn off time of the main thyristor. So you can calculate from square root of LC into pi minus 2 sin inverse of x by s. So here again you have to remember, here still now we have not calculated what will be the value of L and what will be the value of C. So in this equation also we don't know the value of L and C. Okay, and x we have already discussed in last section. It should be vary from 1.4 to 3, that will be mentioned in the numerical. So now here you can observe, if the value of I naught is increased, that means normal load current is increased. Let us assume ICP is fixed. So if I naught is increased, then what will happen? X is equal to ICP by I naught. So when I naught is increasing, ICP is constant, then what will happen? The x will decrease. When x is decreasing, if you substitute in this equation, when x is decreasing, this part is increasing, or otherwise we can tell that Tc is decreasing. That means duration for each, your thyristor is reverse biased, that is decreasing. So your thyristor may fail, it may not be able to recover completely. So to ensure that necessary turn off time, so the value of x should increase. So that's the reason it is maintained from 1.4 to 3 in practice. Getting it? So now this equation number 4, from equation number 4, I can rearrange this. I want to calculate the value of root LC. So remaining terms I am taking to second side. So this root C I am keeping here. This L I am bringing to second side. This will become Tc by root L. This entire term comes to denominator, pi minus 2 times of sin inverse of 1 by x. So this I am taking as equation number 5. So now we have seen in equation number 2. Equation number 2 we got as root C is equal to x times of I naught by Vs into L. I told you we are going to use it later on. So this I am substituting in the left hand side. Instead of this root C, I am replacing that. So when you replace that, this will become, from here I am rewriting x into I naught by Vs into square root of L is equal to Tc by root L into 1 by pi minus 2 sin inverse of 1 by x. So from this I can calculate my value of L. How can I calculate it? Here there is a root L. When you bring this side, root L into root L, that will become root L square or simply L. So simply these terms will come to second side. So Vs will come to numerator. So Vs came to numerator. X will come to denominator, I naught will come to denominator. So Vs Tc by x times of I naught into 1 by pi minus 2 sin inverse of x 1 by x. So here you can see all the elements will be known to us. What is Vc? What should be the circuit turn off time required? Because every thyristor, that rating will be given. So whatever the minimum turn off time mentioned for the thyristor, add some extra value. So that will be taken as the Tc. So that should be taken in practice. So divided by x times of I naught into 1 by, so remaining terms also known to us. So we can easily calculate the value of L. So L part is over. So let us see how to calculate the value of C. So for that, what I am doing, again I am taking equation number 4. So equation number 4, what we got? Tc is equal to pi minus 2 sin inverse of 1 by x into square root of LC. So from this, I can calculate the value of 1 by root LC. So this root L I am bringing to second side, remaining I am bringing this side. So this will come to this side, 1 by root L is equal to, this term is constant, pi minus 2 sin inverse 1 by x. Here L is removed, so it becomes a root C. This Tc come to denominator, so it will be by Tc. Okay, so this I am writing as equation number 7. So now what I am doing, I am just keeping this in equation number 1. So what is equation number 1 we have derived? Vs into square root of C by L is equal to x by I naught. So in that denominator, that means 1 by root L, that I am substituting from this equation number 7. So when you substitute it, you will get it as Vs, because this 1 by root L, I am just substituting this one. So this will be Vs into root C. This 1 by L is replaced with this one. So it will be pi minus 2 sine inverse of 1 by x into root C by Tc. This entire thing came here. And right hand side is x times of I0. So this I can further simplify it. So root C multiplied by root C, that will become equal to C. So C will be equal to, because C is C. So remaining all terms we are bringing to second side. This will become x into I0 into Tc comes here. X I0 Tc divided by Vs into pi minus 2 sine inverse of 1 by x. So this is the equation we are getting. So here again you can see we are calculating, see, all the element parameters are known to us. We can easily calculate the value of capacitance that is required. I hope designing of the inductor, capacitor, how to calculate the peak value of the capacitor current, how to calculate the peak value of capacitor voltage are clear to you. So now let us proceed for circuit turn-off time for auxiliary thyristor and what will be the total commutation interval. So circuit turn-off time of the auxiliary thyristor. So auxiliary thyristor, what happens? The auxiliary thyristor will be turned off at T2 when the value of IC changes its polarity. You can see here at T2, this is the value T2. So T2 is there. Till that time the IC is conducting in the negative half. So after that, what is happening? The IC is reversing its direction. When IC reverses its direction, actually what happens, up to here, this IC will pass to your auxiliary thyristor, because auxiliary thyristor is triggered at T1. So the current through auxiliary thyristor will be same as the IC. So it will pass. Once it reaches 0 going in opposite direction, thyristor will not current direction allow in opposite direction. So that's why your auxiliary thyristor will be turned off. So up to which instant it will be in reverse bias or turn off condition? It will be in the turn off condition until the voltage across this auxiliary thyristor will be positive. So when that is positive, at the instant t is equal to T4. At the instant t is equal to T4, that output voltage will decrease, or the voltage across the auxiliary thyristor will increase at that instant. That means we can tell that the auxiliary thyristor is turned off for a duration of, because from the duration from T4, because at the T4, and when it is turned off, it is turned off at T2. So that much duration we have to calculate. So same thing I am calculating. So it is for a duration of T4 minus T2. So this T4 minus T2 I can write as omega into T is equal to that angle. So this I can write as omega into T4 minus T2. So you can observe here T4 and T2. So T2 is coming here and T4 is this one. So this entire duration is pi. Out of pi, we are not covering the pi. We are covering theta 1 less than pi. So that's why you can write as pi minus theta 1. It is covering pi minus theta 1. So when you substitute the values of theta 1 is sine inverse of 1 by x. Okay. So this omega is 1 by root LC. When it comes to second side, it will become root LC into pi minus sine inverse of 1 by x. So this value comes. So what is the value of x? The value of x is ICP by I0. So this is the value. Let us go to total commutation interval. So it is a time between the instant when you turned on your auxiliary thyristor. You can see here that auxiliary thyristor is turned on at the instant T1 up to the main thyristor is ready to operate again. For this much duration, that indicates the total commutation interval or total duration for which your main thyristor is left free. That means your main thyristor is not working. So that duration we call as total commutation interval. So this interval I am dividing into different parts because it is up to T6. Because you can see at T6, your capacitor current is reaching 0. At T6, your capacitor current is reaching 0. So after this, any instant we can turn on the main thyristor. Because if you see the voltage across the main thyristor, 1. So by TC, it is forward biased. And there are no current through the capacitor. No other elements are working. So that means we are ready to turn on again. After this, we can turn on any time. Like example, in this example, we have turned on at T is equal to T7. It can be turned on at any time. This is the minimum duration for which your main thyristor is left free to recover. So that duration is called as the total commutation interval. So this I am dividing into different. One is I am taking from T1 to T2, then T3 to T4, T4 to T5, then T5 to T6. This is the total duration. So using this I can easily get it. C1 to T2 is there. Here this will be T4 to T2. So please change it. So our complete duration is coming. Okay. So I am just changing this one. Sorry, because there is a mistake while writing. Okay. So I have changed this one. Okay, so let us proceed. Let us calculate each one of them. Then we are going to substitute in this equation. So let us take T2 minus T1. So what will happen at the instant of T2 and T1? So IC completes one negative half cycle. You can see here T1 to T2, it completes one negative half cycle. And how much it is completing? It is completing one complete negative half cycle. That means pi radians, or I can write as pi by omega naught in degrees. So pi by omega naught it is completing. So it is completing pi radians. What is the frequency omega naught is 1 by root LC. So we can tell the duration T2 minus T1 is equal to pi by omega naught, because omega naught is radians per second and pi is in radians. So radians by radians per second. So that will give you time. That is the reason I have written like this. So this will come as pi root LC. So this is easy only. Let us now see the duration T2 to T4. So during T2 to T4, you can see the current in the capacitor is gradually increasing. It will reach its maximum value. Then it will reach I naught. By the time it reaches I naught, then what will happen? It will current will start passing at I naught, because the load is having a current of I naught. So same current will continue through this one, because the voltage is not equal to the supply voltage, or that freewheeling diode does not start conducting. That load will not allow the current to change. That's why current is remaining constant. So I have to calculate T4 to T2. So this is the sine wave. Total duration is pi. Out of pi it is conducting up to pi minus theta 1, because the remaining duration is theta 1. So same thing I am substituting here. T4 minus T2 is pi minus theta 1 divided by omega naught. That gives the time. So this will be pi minus theta 1. Omega naught is equal to 1 by root LC. So this will be pi minus theta 1 into root LC. So now coming to the next duration, T5 to T4. So from T4 to T5, this is T5. So what is happening? Your current through the capacitor is equal to constant. It is maintained as constant. So what will happen? The capacitor will gradually charge. So by the time of T5, what will happen? It will charge to a voltage equal to Vs. That means it will start from some initial value, that we can call that initial value is Vc1, and it is charging up to the value of Vs. At this instant, let us assume that voltage is equal to Vc1. So same thing I am mentioning here. The IC is constant equal to I naught. Vc increases from value of Vc1 to Vs at T5. So as the Vc is charging sinusoidally, you can see here from this instant from T1, it is changing sinusoidally, reaches negative maximum, reaches 0. So after 0, again it is increasing slowly, and it has reached up to Vc1. It has reached up to Vc1. So total duration of this half cycle when it reaches, because you can see at the time of 0 crossing, the current through your capacitor will be maximum, because then the voltage will be 0. From that until this current 0 ideally reach, it will reach the Vs if it is changing sinusoidally, but it is not happening. The moment the current has reached I naught, it is stopping up to there. So when it is reaching I naught, you can see here this total duration is pi, or from the center if you take it, this is pi by 2. It is stopping before. This is pi by 2 minus theta 1. So that's why I have taken it. Value of the capacitor voltage at that time Vc1 I can write as Vs into sine of pi by 2 minus theta 1. It has reached up to there. So now after that IC is equal to I naught constant, so it will charge linearly. So we can tell that I is equal to C into dV by dt. I can write I is constant, that is equal to I naught, current through the capacitor, C into change in voltage. It is changing from Vs into sine pi by 2 minus theta 1 at t is equal to T4 to Vs at t is equal to T5, divided by the time duration is T5 minus T4. So from this I am calculating T5 minus T4 is C into Vs by I naught into 1 minus cos theta 1. So I think it is clear up to here. Then coming to T5 to T6. From T5 to T6, what is happening? T5 to T6, you can see the freewheeling diode is conducting. So the capacitor current will slowly goes on decreasing, and the capacitor voltage will goes on rising after this one. So let us see that what is happening. Why it is rising? Because inductor is not allowing the sudden change in the current. That means we can tell that energy stored in the inductor is transferred to capacitor during this duration. So what will be that entire duration for which it will go? Here you can see at this instant the value is I naught. It is reaching 0, because LC circuit it will follow the sine wave. Here it is reaching from maximum to 0. We can take it as a cosine wave. So how much it is completing? 1/4 cycle. So you have to take it as 1/4 cycle, or pi by 2 radians. So that's why we can write as omega naught into T6 minus T5. In this duration, it is reaching how much? 1/4 cycle it is completing. Or otherwise from this I can write T6 minus T5 is pi by 2 times of this omega naught. That omega naught will come to denominator. So what is omega naught? 1 by root LC. So I am substituting it. This will be pi root LC divided by 2. This I am taking as equation number 14. So now what I am doing, I am substituting all these durations in equation number 10. So I can write T6 minus T1 is pi root LC, pi minus theta 1 root LC, CVS by I naught into 1 minus cos theta 1 plus pi by 2 root LC. So when you simplify this, here you can see this is pi into root LC. Here again pi into root LC is there. Here pi by 2 root LC is there. So root LC is common. So this will be pi plus pi. That means 2 pi plus pi by 2. 2 pi plus pi by 2 will be 5 pi by 2 plus this is having minus theta 1 into root LC. So minus theta 1 into root LC. Then this term I have copied as it is CVS into 1 minus cos theta 1 by I naught. So using this we can calculate it. I hope that how the different times, that different parameters that came, how to calculate or design the value of LC and other parameters are clear to you. If you still have any queries, you can leave your comments in the comment section below. I will answer to your queries from there. Thank you. Thank you very much.